the chapter is real numbers for standard 10 and part 2. So we found the LCM and HCF using prime factorization in our last video. Now we will be using the Euclid's division algorithm to find the HCF of two numbers. So we will be using the division lemma which we learned in the first part, that is A is equal to BQ plus R. You can express any number as BQ plus R. So let us divide 117 and 45. So divided by 45. So you will get 2 is 90, then 27. So you are dividing 45. Now bring this here, 45 divided by 27. So you will get 1. So we get 18. Now bring this 27 here. So you will be dividing 27 by this 18. So you will get you will bring 27. Yeah. So 18. Then bring this 18 here. Then 2. Then 18, 0. So you are just bringing this 45 here, then this 27 here, this 18 here, and so on, and then finally you will be getting your remainder as 0. Now we will write 117 is equal to, in this format, so 117 is equal to 45 into 2, 45 into 2 plus 27. Now 45 is equal to 27 into 1 plus 18, and then 27 is equal to 18 into 1 plus 9. Now 18 is equal to 9 into 2 plus 0. So you finally got the remainder as 0. Now your HCF will be, HCF is 9. So now here you are dividing 18 by 9 and you are getting as 0. So 9 is the factor. So highest common factor HCF will be 9. So this is a method to find the HCF of any two numbers. So we will do one more problem so that you become familiar with this method. So HCF of 210 and 55. So we will start with 210 divided by 55. So we will get 3. So 165. So 45. So bring this 55 down. So you divide by 45. Divide by 45, you get 1. So you get 10. So bring 45 here. So 4, 40, get 5. Again bring this 10 down. So you will get 2. So your remainder is 0. So you can write this now using this division Euclid's lemma. So 210 is equal to 55 into 3 plus 45. Then 55 is equal to 45 into 1 plus 10. 45 is equal to 10 into 4 plus 5. and 10 is equal to 5 into 2 plus 0. Now 5 here. So now this 5 is the HCF. So you got 0 here in this step. So this 5 will be the HCF. Or you can even think this the remainder of the remainder in the previous step. So 5 is the HCF of 210 and 55. Now we have to find the HCF of 3 numbers. The previous problem we did the HCF of 2 numbers. Now we have to find the HCF of 3 numbers. So this division algorithm is much easier than the factorization method. So now for now finding the HCF of 3 numbers, first you have to find the HCF of any 2 numbers. Now you will get an HCF, some value, that value and this the third number you have to find again HCF. So let us start with these 2 numbers 441 and 567. I have already done it. So here I will write it down. 567 is equal to 441 into 1 plus 126. So 441 is equal to 126 into 3 plus 63, and 126 is equal to 63 into 2 plus 0. Now this will be 63 is the HCF of, so HCF of 441 and 567 is equal to 63. Now you will find the HCF of HCF of now the third number and this HCF. So 693 and 63. So if you divide 693 by 63, you get 11 and the remainder is 0. So 693 is equal to 63 into 11 plus 0. So 11 is the HCF. So HCF is equal to, so HCF of 441, 567 and 693 is 11. Now we have learned to find the HCF of 2 numbers. Now we can also express the HCF of these numbers as a linear combination of the numbers. So HCF of 2 positive integers a and b can be expressed as a linear combination of a and b. That is, HCF is equal to, that value is equal to xa plus yb for some integers x and y. And also this representation, this value of x and y is not unique. So now I'll explain this with doing the problem. So 81 and 237 will find the HCF using the Euclid's algorithm. So 237 will write it down. 237 is equal to 81 into 2 plus 75. 81 is equal to 75 into 1 plus 6. 75 is equal to 6 into 12 plus 3, and 6 is equal to 3 into 2 plus 0. Therefore, HCF is 3. HCF of 81 and 237 is equal to 3. Now we have to write this value 3 as 81 into some integer plus 237 into some integer. So we'll we'll see how it can be done. So we'll start with 3. So 3 is equal to, so we'll start with 3. So 3 is equal to, from here we will take it out. So we will write 3 is equal to 75 minus 6 into 12 from this step. So I'll write the numbers as 1, 2, 3 and 4. So this is from step 3. Now you should remember that we should always convert 3, 6, 75 only. So we will write here as 75 minus. Now I have to change 6 as 81 minus 75. So 6 is 81 minus 75 into 12. Just converting the 6 from, this is from 2. So simplifying, 75 minus 81 into 12 plus minus into minus plus 75 into 12. Now adding these two, so this is 75 into 1 plus 75 into 12. So this will become 75 into 13, distributive law, is equal to 81 into 12. Now I will convert this 75 now. So always remember to convert only these remainders. So this is equal to, 75 is equal to 237 minus 2 into 81 into 13 is equal to 81 into 12. Because why we are doing is, we have to ultimately write as 81 and 237. So this will become 237 into 13 minus 13 into 2, 26 into 81 minus 12 into 81. So this is equal to 237 into 13 minus 38 into 81. So this is, we have written this as in the form of XA plus YB. So this is of the form, XA plus YB. It is 237 into 13 plus minus 81 into minus 38. So here value of x is equal to 13 and y is equal to minus 38. So now this value of x and y is not unique. You can have another value of x and a corresponding value of y. So that is not in the scope of your NCERT syllabus. So I am not teaching that. Hope you understood this. I will repeat again. You have to first find the HCF of the two numbers and write it down like this. And now we will have to start with the HCF. 3 is equal to, start from this, 75 minus 3 is equal to, and then again in this place of 6 you will change 6 as 81 minus 75 and then simplify, and then in the next step you will substitute 75 is equal to. So this is from 1. Be careful in your calculations, simplifications, and then finally you will get it. So you are bringing it to some 237 into some number plus 81 into another number. So that is a linear combination.